So let's practice graphing some polar coordinates. Let's say we have the function in the polar coordinate plane r is equal to sine theta. So the radius, which is the output, which is the dependent variable, is equal to the sine of whatever input or whatever angle that we input. So again, just a reminder, theta is the independent variable and r is the dependent variable. And it's analogous to y and something x. X is the independent and y is the dependent. Alright, so very similar to x and y coordinate plane system where we want to graph something, we can usually just start by plugging in some values. So we have our theta and we have our r. So let's just plug in some. Let's just start plugging in some values. Usually it's good to start with 0. So sine of 0, we get an output for the radius where the radius will equal 0. So we're going to start plugging in some other values. So usually some good numbers are pi over 6, pi over 4, pi over 3. These are known values, so you don't have to really use a calculator. Pi over 2, pi, 3 pi over 2, let's see. And then we'll just do like 2 pi. That should be okay. And then I will give you a much faster way to do this in the next video, but for now, let's just go through this. So if we plug in pi over 6 for sine, we get, let's see, sine of pi over 6 is sine of 30 degrees, which is 1/2. Sine of pi over 4 is sine of 45 degrees, which is root 2 over 2. Let's just estimate root 2 over 2. Root 2, I believe, is around 1.4, and then over 2, so I don't know, around 0.7 or so. It's a fair estimate. Pi over 3 is root 3 over 2. Sine of pi over 3 is root 3 over 2. So we'll just say, let's see, root 3 is around 1.7 or so. So here we'll just say it's around 0.8. So just confirm that on your calculator. If that's wrong, just put the right value. Sine of pi over 2 is 1. Notice how it's increasing. Sine of pi now is back to 0. Sine of 3 pi over 2 is negative 1. 3 pi over 2 is, let's see, 270 degrees, so it's negative 1. And then sine of 2 pi, we're back to 0. Alright, let's see if we can graph this. Let's take a look here. So we have, again, we don't have an XY axis anymore. We have a theta and r. So we don't really label. You could sort of label it like this. Like that's that's radius 1, that's radius 2, that's radius 3, so that it's very symmetric as you plug in points, but you don't have to really do that either. Alright, so at theta is equal to 0, we're at 0. So here, let's plug in the points with different colors. So right here, theta is pi over 6, we're at 1/2, so pi over 6 is a little bit less than pi over 4, so a little bit less than halfway between these two, so it should be around here, and then we're 1/2, so somewhere around here. Pi over 4, we're at 0.7, so pi over 4 is a little bit greater than that, and we're a little bit greater than 1/2, so around here. Pi over 3 is greater than that, we're about 0.8, so maybe right here. And then pi over 2, finally, we're at 1. And then so now we know that this is symmetrical, and I'll show you in the next video why it's symmetrical on this side. But for now, just believe me that it is symmetrical. So it will just go something like that. And then 3 pi over 2, we have. So this is one of our points. Sorry, it should be radius comma theta. So the way we write that is negative 1 comma 3 pi over 2. So 3 pi over 2 is 270. So we're here, as the angle is right here, but it's negative 1. So instead of being at 270 and going 1, which would be here, we go negative 1, so we go the opposite way. So it would be right here. Notice how it's the same point. So it's just going to keep repeating itself from now. So now we're done drawing the graph. So it would be something like this. Again, plugging in points for polar coordinate plane is a bit tedious, so stay tuned for the next video where you will find a much faster way to graph it. See if you can think of the faster way yourself before you watch the next video, and then go ahead and watch the next video afterwards. Sorry, see you guys in the next video.